Okay, so today we'll be going over some notes. We'll be talking about slope, also known as rate of change, and has a bunch of other names that we'll go over here in a second. So, first of all, definition. What is the rate of change? What is the definition for slope? So slope and rate of change mean the same thing. All right. So what is the definition of that? Well, the definition of that is the change in the height of a line divided by the change in the horizontal distance. Also, we call that change in y divided by the change in x. So you're going to see this a few different ways. So if you ever see a triangle, okay, we also call this delta in math. And basically all you have to know is that if you ever see that triangle or delta, what that means is it means change in or difference. So it basically means that you need to subtract. All right, hopefully by now we know that those words mean to subtract. So the table shows the distance a band marches over time. Is the rate of change in distance with respect to time constant, and what does the rate of change represent? So is it constant, yes or no? Well, we have to figure that out. So we know that because if it's proportional, right? Or if it's changing by the same amount every single time. So what we have to do is we have to look at how the x changes and how the y changes. So x is always going to be on the left of the table, y is always going to be on the right of the table. So let's take a look at how the x changes first. So to go from 1 to 2, we add 1. Okay, and over here, that's where we would put our delta x, our change in x. To go from 2 to 3, we're doing plus 1. To go from 3 to 4, it's plus 1. To go from 260 to 520, all right, that's also going to be plus 260. To go from 520 to 780, so we would take 780 minus 520, and that's going to be plus 260. 780 to 10th 40 would be plus 260. So every time, if we notice, my change in y is the same every time my change in x is the same. So that means my ratio is the same, right? So if I take my change in y divided by my change in x. So we would take 260 divided by 1. And if we do it for every single time, so that's for the first change. So then let's do the second one. It would be 260 divided by 1. And if we do it for the third one as well, right? 260 divided by 1. So hopefully we see a pattern now that they're always the same. So is it constant? Yes, because it's changing by the same amount every single time, right? So because it's changing by 260 every time the x changes by 1, that means it's constant. And all my ratios are the same. 260 divided by 1 is 260, 260 divided by 1 is 260, 260 divided by 1 is 260, meaning that this is constant because we have the same ratio. So what does the rate of change represent? Well, we would write this as 260 feet per minute. Feet per minute, because it's a y divided by the x. So feet per minute. That's what it represents, feet per minute. Okay, so let's take a look at slope. So slope is the same thing as rate of change, right? The graph below represents the points from example 1. So if we take a look, we know it's constant. Why? Because it's a straight line. So if we were to graph these points above in the table, it should make a straight line. Now we know that it's also going to be constant because it's a straight line. Okay, it starts at 0, 0, meaning that it is proportional as well. So that all we're doing is we're taking the table from here and transforming it here. Well, I can take a look at this, and I know, again, the change in my height, my change in y, right? So change in y divided by change in x. So it goes up by 260. So then 260 would go on top, and it's positive because we're going up. And then right by 1. So if we're going right by 1, that's my change in my horizontal distance, my change in x. And it's positive because we're going to the right. So I have positive 260 divided by positive 1, which would just be 260. And it would be your y over your x, so feet per minute. So it's the same exact answer as the one above, it's just shown in a different format. Shown as a graph instead of a table. So for the bottom two, you need to find the slope of each line. So again, we need to do the rise over the run. So we've talked about this before. Rise over run. Change in y over change in x. So find 2 points on the graph that we can work with. So points we want to work with are points that fall on the grid lines. Alright, so this would be a good point right here. It falls on the grid lines. This would be another good point right here because it falls on the grid lines. So now going from this point to this point, we always want to go from left to right. We never want to go from right to left. Always go from left to right like you're reading a book. And it's my how far I go up. So I go up 1, 2, 3, 4 times. So my rise would be positive 4 because I go up. When I go up, it's positive. And then I go right 1, 2 times. So it's positive 4 and then positive 2. So then my rise over my run would be 4 divided by 2. 4 divided by 2. Hopefully we can do the math on this. Would just be 2. So the slope of that one is 2. Y'all are going to do the second one on your own. Oh, sorry. Actually, I'll do the second one on your own because you have your own. So I'll do this one for you with y'all as well. So again, pick 2 points that fall on the grid line. There's a good one. There's a good one. We do our rise over our run. Now if we look at this, this one looks different, right? This one from left to right was going in an upward direction. This one from left to right is going in a downward direction. So now when I do my rise over my run, it's going to be a little different. Starting from the point on the left, traveling to the right, we go down 1, 2, 3. So now I'm going down 3. And remember on a line, if I'm going down, then it's going to be a negative value. So instead of being positive 3, this is going to end up being negative 3. So my rise would be negative 3. And then my run, we go to the right 1, 2, 3 times as well. So then my run is going to be positive 3. So now I have negative 3 divided by positive 3. If you put that in your calculator, hopefully we know by now, a negative divided by a positive is a negative. So negative 3 divided by positive 3 would be negative 1. Okay, you're going to do these two on your own. Alright? And we're going to talk about the slope formula. So the slope formula, before I forget, when you do these two on your own, you need to ask me or Mr. Kimmel, come up to us and so we can double check your answers and tell you if you're right or wrong before you move on to the rest of the notes. Understood? Okay, so for slope formula, m is equal to the change in y divided by the change in x. Well, how do we write that? Well, what you're going to be given on the STAR test and on all your formula sheets is y2 minus y1 divided by x2 minus x1. I'm going to go over what this all means here in a second. So this is the change in y divided by the change in x. We use this formula when you're given 2 points and nothing else. You can also do it from a table. So when you're given 2 points, you can use this formula. Okay, so looking at this, A, you have 2 points. Every point has an x value and a y value. Okay, so we're going to call this first point, point 1. So then the coordinates of this point would be x1 and y1. So we have that little subscript there. Okay, then for this second point, this is the second point, so the coordinates of this point are going to be x2, y2. So then we do the change in y divided by the change in x. So we do y2. y2 is the negative 2. So we would start with the negative 2. So for y2, we do negative 2. Okay, that looks bad. Let me fix it for you. Minus y1. y1 is the 0 right here. So minus 0. That is going to be divided by the change in x. So starting with x2, which would be the positive 3, minus x1, which would be the negative 1. And you want to make sure that it's not just 3 minus 1. It has to be 3 minus negative 1. Make sure when you're doing this, if you ever forget, put the numbers in parentheses. If you put the numbers in parentheses and put the minus sign in between, that'll help you remember not to do that. Okay? So it's going to be y2 minus y1, x2 minus x1. And when we do this, negative 2 minus 0 is just negative 2. 3 minus negative 1. Well, the minus and negative becomes a positive. So it ends up being 3 plus 1, which would be 4. And then if we take our calculator, negative 2 divided by 4 can be simplified to negative 1/2. Okay, let's do the second one. So again, identify your x and your y. We have x1, y1. This is x2, y2. This is the x value of the first point, x value of the second point. Y value of the first point, y value of the second point. So using our formula, we're going to take the y value from the second point, put it in parentheses, so it's positive 1, minus the y value from the first point, which is going to be negative 2. Make sure you put it in parentheses, that way you don't forget. Divided by the change in x. So starting with the second value from the x, which is negative 2, minus the x value from the first point, which would be negative 2. Then when we work it out, 1 minus negative 2 minus a negative becomes a positive. Again, if you're not sure how to do this, please use a calculator. 1 minus negative 2 would be 1 plus 2, which ends up being 3. Negative 2 minus negative 2, that's negative 2 plus 2. Negative 2 plus 2 is 0. You can't divide by 0. Right? We cannot divide by 0. It is impossible to divide by 0. So then, therefore, this is actually going to be what we call undefined. And we'll talk about what that means here in a second. Okay, you're going to do the next two on your own. Please check with me and Mr. Kimball before you move on. Okay, the last things we need to know here. We have what type of slopes we have? A positive slope from left to right will move in an upward direction. So from left to right, it's moving up. A negative slope from left to right will move in a downward direction. So from left to right, it's moving down. So if you were to follow along with your pencil, you'd notice your pencil's going down if you go from left to right. A zero slope means that from left to right, it does not go up or down. It just stays neutral. A zero slope looks like this. So it's kind of a flat horizontal line. And an undefined slope, we just talked about that. It just goes up and down vertically. Reason being, the zero slope, rise over run, has no rise and it's all run. So this would be something like 0 divided by 4. No rise, but it's still running. Undefined would be like what we did earlier, 3 over 0. It's rising, but it's not running. So it's going up and down, but it's not moving left or right. This is not going up or down, but it is moving left and right. Okay, when you're done with that, there's a couple IXL assignments that you can work on. If you have any questions, please ask me or Mr. Kimmel.